All right, so I did this last night, so it must be, we're at the hump. Today is like our hump day. Once we get out through this class, we're actually more than halfway. So 5 weeks ago was the first time we all met, and 5 weeks from now is our last time we will be together as this class. So today's that middle point. And so this is the study set that you can always, and a lot of people find it to go back. I also try to post the answer key when I remember to scan it. So because some people like to visually go back and look at the stuff, but it can help to go back and listen. You don't have to watch, but to listen, because sometimes the explanations are there. And yeah, back to the question that Omar just asked, if you guys ever have a problem like that, please just send me an email, because there are some weird quirks. And actually, there's another comment I want to make. It was a question Stephen had asked me in office hours. I had made a comment last week that I write on your assignments. And that's actually that when you go in, you have to go into gradebook. Actually, when I write on it, I have to actually grade it. If you go into gradebook and pull up that assignment, you can actually see where I wrote notes on it. If you go into the assignment, you can't see my notes. You can only see what you submitted. So you go into gradebook once I put a grade on it. If you submit something really early, sometimes I'll say, hey, make these changes, and you can resubmit it. But today's lab is due, so if you want me to look at your lab, you're gonna have to find the time to come to my office hours at 6 o'clock this evening. All right, and something that really helps, in case you don't know, is if you take a picture of what you want me to look at and put it on your computer, you can do a share screen like what I'm doing right now, and then I can just look at it and talk it through with you, and it will only take us like 2 minutes for you to fix stuff. So it's a really handy feature. All right, barium, no Roman numeral, and SO4 is sulfate. All right, CO is cobalt. And this does get a Roman numeral, so we do have to worry about charges. So I look up the PO4, and PO4, and this is why, rather than having separate pages, if you actually write on your periodic table, again, just these polyatomics, there's many, many more, but let's keep it simple right now. We're just getting this idea of how it works, that it is PO4 and has a -3, so that is phosphate. So again, the number of oxygens are going to change in a moment. Phosphate has a -3, so the cobalt must have a 2. Whenever you see that 2-3 ratio, they're going to swap. There's a few exceptions there, and we'll talk about that as we run into them. So this would just be cobalt 2 phosphate. All right, CD is cadmium. This is actually what's in your cell phone batteries that make your cell phones toxic. So cadmium is right above mercury on the periodic table. And we know mercury's like been banned. And if you have a pea-sized amount of mercury in a lake, huge lake, it has killed everything in that lake and made that lake toxic for, I forget, like decades or something. Like you're not allowed to fish in it. Cadmium is just as lovely, and we have a lot more than a pea-sized amount now in the environment because of all our cell phones. And you guys, by the way, we'll be doing a paper on an element. So if you want to pick an element that you want to research, you can just let me know by email. All right, NO3 is nitrate. We want to make sure right number of oxygens, so nitrate. So we're looking inside at the NO3. The -1 is the charge of nitrate, and there's 2 of them, so the cadmium's a 2 charge. So a comment about cadmium, zinc, and silver. So these guys here, and even gallium. There are still a lot of places that you will find that they say those do not get a Roman numeral. The actual rules are from whatever the American Chemical Society that they do get Roman numerals, just the S block and aluminum, they have fixed charge. So we're going to go with a Roman numeral. I mention this because some of you will go on to more chemistry. do whatever your teacher wants you to do. I honestly, I prefer showing a Roman numeral so we stay consistent with the rules. All right, there's a lot of nuances that we run into. Showing parentheses can be really helpful. So the ClO2 would be, you can put a parentheses around it. It's a learning technique, it can help. So that is lithium, no Roman numeral, and then the ClO2 is where we look. ClO3 is chlorate. So when you lose an oxygen, so you make yourself a little chart. You don't need a huge chart. When you lose an oxygen, it becomes an ite. And actually, once you do the whole lab, if you do it sincerely with your own brain cells, trying to learn the pattern, then you'll have this. So lithium chlorite. All right, aluminum or alumininium. I think I said it right. Nobody else in the world calls it aluminum except in this country. Everybody else calls it the British way, which is alumininium, I think. They had a joke last year because I could not say it the correct way. No Roman numeral because it doesn't, it's the d electrons, having any d electrons. All right, this is just ClO. The 3 is on the outside. So when you take away 2 oxygens, you put the hypo on it. So it's, the ite means one and hypo means another one. So it's aluminum hypochlorite. All right, nickel. It's going to get a Roman numeral. The I is a -1, and this is something I keep the chart simple because there are patterns, and once you've done it and get the patterns, you don't need tons of information there. Chlorate, bromate, and iodate all behave the same because they are in the same family. So Cl, Br, and I all behave the same. So chlorate, bromate, and iodate are all O3s with a -1. So this is the iodate. So I don't write all of them down. You can write them next to it really small. The family trend does not include the second row of the periodic table. The second row is special, and it again has to do with the d electrons. There are no 2ds, and they actually are the only row that obeys the octet rule, kind of, sort of. Anyway, in 222, we look at that in a little bit more detail. All right, gold absolutely gets a Roman numeral. Au is gold, Rm. And then, again, you put a parentheses, BrO4. That would have been bromate. It was BrO3. So if we add an oxygen, that becomes per, and then 8. So again, I don't like those huge lists that have like 200, I'm being exaggerating, maybe it's only 150 polyatomics. You do want to understand the pattern, and it is a pattern. So this is per bromate. When you change the number of oxygens, the charge stays the same. So it's still a -1. So it's gold 1 per bromate. The 4 is the number of oxygens. It has no effect on the charge. All right, so now we're going to write formulas. Aluminum is Al+3, and nitrate, this is where parentheses can be helpful, NO3 with a -1. So writing your ions, you can even show parentheses. You don't have to. In this formula, we will have to show parentheses. 3 inside to be nitrate, 3 outside to balance the charge. All right, iron is a +3, SO4 is sulfate. It has a -2. So again, you would look here, you see it's sulfate. 8 does not mean 3 oxygens. Again, sulfate and phosphate have 4 oxygens. So there's actually a number of others also, but we're not going to worry about them. If you take 221, you can worry about it then. So the subscripts, I'm sorry, the charges switch, and now they become subscripts. Again, in the final answer, we don't show charges, we just show the ratio. Right, calcium is a +2, so it's in the 2A's, and phosphate is PO4, and Again, I'm just showing how to use the parentheses. If you like them, you have to use it on this one. 3 calciums for every 2 phosphates. This is why on the lab, you had to show your charges, because once you show your ions, you guys get it once you see the ions. So it's a really good habit. So when we used to have quizzes live in class, the students who got done the fastest were the ones who wrote the most. They wrote their ions and then they could put together. The students who sat there and tried to keep everything in their head, they actually took the longest, because we all know what's going on up in our brains. All right, OH is one of these 3 here. These 3 are actually really common, and they have slightly different pieces to them. So it is called hydroxide. It is written as OH. If you write it as HO, I don't care. So it doesn't matter if you write it as HO or O. There might be somebody who cares out there, but I don't. So a lot of students do write it as HO. You do need the parentheses around both the O and the H, and then the subscript 4 goes on the outside. All right, sodium is a +1, and then ite means we find sulfate, take away an oxygen, but you keep the charge. So it is SO3, and it has a -2. So 2 sodiums, and then just 1 SO3. Now, this back question, Emily, you had asked me, you do not need parentheses on this. Technically, you do not use parentheses. I have found for a high amount of students, those parentheses really help them. And so you would show it like that. We don't show the 1. I would not mark you wrong. My son is with another teacher, and his teacher marked him wrong. And so it was actually some students who illuminated me that everybody sees things differently, and the parentheses help a lot of students to see that the NH4, ammonium is not on the periodic table. It is this polyatomic. It is special because it's a cation polyatomic. It does not have a +4 charge. That is a +1 charge. That 4 is a subscript. So it is NH4. That's why the parentheses are helpful. This is PO4. It has a -3. So you're going to need 3 NH4s for every 1 PO4. So technically, that's how we would write the formula. If you put a parenthesis around the PO4, that is fine. All right, gold 3 is AU with a +3. And then chlorite means we find chlorate, and you take an oxygen away. So ClO2, and it has a -1. Again, you can show it as just negative. Again, for a lot of students, showing the 1 helps them. So AU, and then ClO2, and then the 3 is on the outside to balance the charge. So it is very systematic, and it's just taking the time to show it carefully. So actually going about it in a calm manner, it can be like a meditation. Okay. This one, you guys all read it as periodate. It is per, and then there is iode for iodine, and then 8. This is the one where we add an oxygen. So it's IO4, and it has a -1. Google has no idea what periodate is. So this ends up being a red flag for teachers, the students who are really following it systematically, and the students who are trying to use Google, because there is a classic Google answer for this one for some reason. All right, the 2 will come down, and that's what magnesium periodate would look like, or per iodate would be how a chemist would say it. All right, so the trick with the acids, again, you can just write yourself a little note on a note card that you have attached to your periodic table if you don't want to write on your beautiful periodic table. For acids, the trick is that the 8 becomes ic, and ites become OUS. So again, I had a student who said acids are icky and they burn us. So this SO4 was sulfate. You put parentheses if that helps. So it's sulfuric acid. If you called it sulfic acid, they add an extra syllable. It's just how it's always been named. So, all right, one less oxygen means it's sulfurous. The OUS is one less oxygen. The word acid is used in place of hydrogen. All right, this is the IO4, which is periodate, so it's per-iotic, not periodic, per-iotic, and then acid. So back to that reasoning, and go back, make a note to yourself. That's why when you correct it, use a different color so you know what you want to go back over. All right, HBr is special. If there is no oxygen, we use the hydro prefix. So like HCl is hydrochloric, this is hydrobromic. It has to do, this was a question in the video, nobody answered me. Damon, I don't think you did, unless you did. And it has to do with the meaning of oxygen. Oxygen was named oxygen because it actually means acid former. And that's what they thought acids had oxygen. And then they found out they were wrong. They have hydrogen. And yeah, so that's probably why they had this name, because they couldn't understand why there was no oxygen present. But it gets the prefix hydro when there's no oxygen there. All right, carbonic is H2CO3. So carbonic was carbonate, so CO3 -2, and that's why we have two hydrogens. Phosphoric is phosphate, so it's PO4 with -3, so H3PO4. Bromic would have been bromate, so BrO3, so HBrO3. And hypo is HBrO. So capitalizing correctly is important. So hypo is when we go down to just one oxygen. I do want to make a comment because a student got really mad at me one year. And really, there's no reason to get mad over any of this. It's just a chemistry class. That's all this is. It's just a naming way. In Europe, they actually write for the hypos, they put the oxygen in the middle. And I mention this because a lot of you use Google, use other sources. You may find this one written like that. And he said he wanted to know why, and I just said that's how they do it. Whereas we show it like this with the oxygen always at the end. So they're both fine. It's not a big deal. All right. When there is more than one, they always show the oxygen after. So I would recommend we show it the way we do show it in the here. All right, acids are special. This is actually a really important question. And it has to do with when hydrogen becomes a +1, it is a proton. There's no electrons. There's no shells. It is just a proton. And it is desperate to find protection. Protons don't want to be alone. They're hidden deep, deep, deep inside. And so because that proton is desperate to be with something else, you know, like we as humans, sometimes people can't handle being alone and they're desperate. This is beyond our desperation. It has to be. And so they are special because of that. They're very useful because of that, because they're highly reactive. So we use them for etching. It's traditionally glass, but it's how they etch the silicon wafers to allow the technology age that we are in, that is growing exponentially. They also burn, they eat away at metal. They are molecular. That is really important to realize. They are not ions. They are actually, hydrogen is a nonmetal. And so this is actually a covalent bond. It is not until it is placed in the water and the water pulls the hydrogen ion off that or the proton off, that you suddenly have the ions there. All right, any questions from the first page? All right, my clock's up there. That's why I'm always looking to see, because we have a lot we can do today. So this is normally a 3-hour class, and they wouldn't let me schedule it as 3 hours. And I scheduled next term for 4 hours. And they keep telling me nobody's going to sign up. And I said, I don't care. I'll be thrilled to teach nobody, because I'm a nobody too. So, so this is back to Stephen's question from earlier. These are molecules. They are molecular. They are 2 nonmetals. They usually are much more complex. For naming, we're always only naming binary, which means 2 words. So going back to the first page, that's why with the polyatomics, finding your 2 pieces. So we have ammonium and we have phosphate. So everything had 2 words. So there's always 2 parts. These, because they are absolutely connected together by that covalent bond, like your arm is to your shoulder, this is where you tell me what you have. You also do not reduce. This is not a ratio. So that's why it's shown as N2O4. So ionic, we do reduce, but here you just write what it is. So I have 2 nitrogens. First element, just say the name, nitrogen, sulfur. And then the second one, we end with "ide." And I don't care if you say tetraoxide or tetroxide. There's no clear rule there. Those are small nuances that are personal preference. And so sometimes I write tetraoxide and sometimes I write tetraoxide. All right, 2 sulfurs, 2 bromines. This is where in the chart we did the other day and in your quiz, if something is covalent, no ions. You leave that blank. Or you can draw me a beautiful picture of a pumpkin. All right. Xenon and then 4 fluorines. So xenon is considered a nonmetal. It is a noble gas. It does not do this naturally, but man has made several of the noble gases into compounds. All right. This was a question on your last homework set, and actually we'll see it again. And is a question that a lot of people leave blank on the previous homework set, and I let you get away with it. But on this one, hopefully you wrote something. So ionic, I've done this, I know, on the board or on my sheet several times. So ionic is metal, non-metal. So the metal is positive, non-metal is negative, so cation, anion. And the cat is losing electrons, and the anion is gaining electrons. So this is the key here. This is an electrostatic attraction. It's kind of up to you if you write all this. Hopefully it's getting to the point where it's just there and you just know it. It is just an attraction between the positive and negative. So this is back again to the question earlier. It is why we don't say die, because it is not attached, it's attracted. You put it in water, they're now attracted to the water. And so it is a ratio. That is as opposed to the molecular. So molecular means that we're dealing with covalent bonds. So the compound is considered molecular, the bond is called a covalent bond. They're sharing electrons. And this is between 2 or more nonmetals. Is that what I asked? Yeah. There is no charge. Next week, we're going to get into Lewis structures. Yeah. All right, number 55 has a star because it's making you, once you see how it works, everybody always has a question with this, but if X has 2 valence electrons, X would be a +2. if z has 7, z would be a -1. I didn't want you to actually fill in any elements. I just wanted you to write what the ratio of x and z would be. So xz2. So that's what I was looking for. And most people are like, oh, had no idea. But now you do. So if you ever see this question again, you would know how to approach it. This is actually what Mendeleev did in figuring out his periodic table, is he looked at the ratios and found similarities. So if x has 1, it's going to be x with a +1. Z has 6, it would be z with a -2. This would be like oxygen's family. So in this case, we'd have 2 x's for every 1 z. All right, x has 3, z has 5. So 5 means it's a -3. It needs 3 more to make it to 8. So the answer would just be xz. It's a 1-to-1 ratio. And then the last one, halogen means it's x -1. So again, if you filled in like chlorine or something, great, just right next to it with a different color what I was going for. Earth metal means it's a +2, like calcium. You always show the cation first. So the answer is ZX2. So you need 2 x's for every 1 z, but we always show the metal first, the cation first. And that's all that was looking for, is the ratio. All right, here you just figure out your charges. Cobalt's a +3 in both cases, so A is the answer. On B, when you figure out from the oxygen's charge, copper's a +1 versus a +2, so they're not the same. On C, potassium's 1 because it's an alkali metal, and aluminum's a 3, so they're not the same. And then here, magnesium's a 2 and sodium's a 1. This question actually came straight from a midterm. That's probably why it's ABCD. And I put it on the homework because so many students couldn't figure out what it was asking. But you just had to figure out what your charges are for the cation. You're just looking at the positive ion, and if they come out the same, you pick that answer. All right, on this one, we know P, so we just find X. So X must be a +2 for this ratio to work. Here, chlorine's a -1, so again, X is a +2. CO3 is carbonate, so you look at that list, and since there's 2 X's, X would be a +1. So each X is a +1. All right, now we're doing it the other way. If sodium's +1, X is a -2, and if calcium's a +2, X is a -1. So it was just, it didn't want you to fill in X, it just had said what would the charge be in this case. All right, and then these last two go together. They are not asking the same thing. Molecular means the compound, and it means that we have only nonmetals. There are 3 answers here, and this is, a lot of people come and ask me this question. It is not A, those are metals. If you see metals present, which we see in A, C, and F, you can cross them out. So B, most everybody gets B, that, okay, I have non-metal. A lot of people miss D. It is 2 chlorines. Those 2 chlorines have to interact somehow. They are both to get to an octet, and so they have to share. And then acids, as I talked about, it is a molecule until it's put in water. So that is considered, it is a special type. It is a very polar molecular, and we'll be talking about that next week. There will be a pre-lecture for next Tuesday again that should help you, but there was a pre-lecture for today that did not show up till yesterday because somehow it didn't get saved correctly by your teacher. And I had a student in my other class, because they're like 2 weeks ahead, and she said, I didn't watch it. Should I leave? And I said, no, just stay, because there is some kind of magic that happens from being here now. Even though I can't see any of you, you're all black boxes. And then when she watched the pre-lecture after, she said it actually helped her with both parts. So It is always helpful to watch it beforehand, though. All right, the covalent bond is the bond. And so you just need nonmetals. So we still have the same answer, but F is also an answer. F has both ionic and covalent bonds. If it has an ionic bond, it is an ionic compound, but it can have a covalent bond. So polyatomics are covalently bonded within the polyatomic. All right, does anybody know the answer to the last one, what the next number would be? Your bonus point for the day.
610.
I have no idea who said that.
Maddie.
Maddie, why?
Because, so if you take like number 89, to get to 144, you'd add 55. So in the last one, you would add 144.
Or the 233 and 377.
Oh, yeah, 230.
Yeah. So
yeah.
it was just adding. Yeah, Bill Gates' program, these are done in Word. He renumbers everything I do. He thinks he knows more. And so I just decided to just do whatever number I wanted. But she's right. It is just adding the previous number from the study set, the previous two numbers together. So she gets my bonus point. Any other questions from the study set? I'm going to move to the lecture part. All right, I'm going to stop recording.